So just hang on to that equation, folks. Just let it sit there. That's the combination of equations 1 and 2. And if I had to multiply, it'd still be a combination of multiples of equations 1 and 2. But I need to do that same process using equation number 3. Excuse me. So I have to use 3y minus y plus 2z equals 8. Now, I could use, so I have to use equation number 3 since that wasn't used in either one of these. I could use equation number 2, or I could use the equation number 1. It's up to me. Well, I'm going to choose to use equation number 1 because it has a positive y, which will eliminate the negative y right there when I add them together. So I'm going to choose to use equation 1. You would have to multiply equation number 2 by negative 1 to create opposites, which there's nothing wrong with multiplying by a negative 1. It's just a little more work, another chance at making a boo-boo. What is wrong with this? What's wrong with this is how I copied down equation number 3. I noticed when I started to combine that I didn't have like terms on top of each other. That's because I copied the x wrong. So here we go. We get 4x. Again, the y's cancel out, so then I just have plus 3z, 3z, hello, equals 13. The y's are gone here as well. That's the first step and probably the most difficult step, is figuring out how to cancel out one of the variables. So now I bring this new equation that I created by eliminating the y's from my first system right here and the second equation right here. I'm going to put them together. So I'm going to write them on top of each other. So what I just did was kind of like my big step number 1. Now I look at this new system, like equation, I'm going to call this A and equation B. I put A and B on top of each other. This isn't like a technical thing. You don't actually need to put these letters next to stuff. It's just trying to help you see the process. And so now, folks, you figure out how you want to either figure out x or y. X or z here. So I'm going to choose to eliminate the z's. This is totally your choice. But if I multiply this top one by 3 and the bottom one by negative 2, I will get opposite z's. So I get 9x plus 6z equals 27. And on the bottom, I get negative 8x minus 6z equals negative 26. So notice the z's will cancel out. So I can figure out here that x, because 9x plus negative 8x is x, equals 1. Awesome. X equals 1. Now that I've found what x is, I can go back to the two equations I was just using, either this one in blue or this one in yellow, either or, and check out those equations. They have an x and a z in it. Well, since I know what x is, if I plug in 1 for x, I can calculate z. I'm going to use the top one. So I'm plugging in 1 for x plus 2z. Whoa, I always want to write y. Naughty. 2z equals 9. So 3 plus 2z equals 9. We're going to get 2z equals 6 when I subtract 3. So then z has to equal 3. Does that work? I kind of did that fast. I might as well just, yeah, it definitely works. When I plug a 3 in, I get 6. 6 plus 3 is 9. So there we go. So we've got 1 for x, 3 for z. Now I got to figure out y. So I need to look for an equation that has an x, or that at least has a y in it. And so I could use any of these equations that we started with because I know what x and z are, and this looks like the easiest one to do. So I'm going to use that equation now to figure out what y has to be. So let's see. X plus y plus z is 5. So 1 plus y plus z is 5. So that means that y has to equal 1. So my ordered pair is 1, 1, 3. X, y, z. And if you plug them back into the other two equations in the system, it should be correct. And I think it is. There's the solution. Let's try